All right, so it's not enough to just add the two equations together vertically. Because if I was to just add these without doing anything before that, you'll notice if I just add, I end up getting, well, let's see, 2x minus 4x is negative 2x. I end up getting plus 8y, and I end up getting a negative 27. This is not terribly helpful because it still has both x's and y's in this equation. So I can't really solve this. Instead, what I want to do is I want to look at these and say, okay, is there any way I can modify them so that when I add them together, I get some cancellation? Well, I know with equations, I can do things like multiplying through the equation by whatever value I'd like, and I don't have to have a good reason for it. Generally, it's a good idea too, because you want to. But for instance, I could take, in this equation, I could multiply that equation through by 2. Let's see what happens when I do that. When I multiply this equation by 2, technically I'm doing this, multiplying the left-hand side by 2 and the right-hand side by 2. So distributing that 2 through, I end up with 4x plus 6y equals negative 12. I'm going to copy the second equation down, negative 4x plus 5y equals negative 21. And you might actually see why I did this now. By doubling all of the, by doubling the entire first equation, I made it so the coefficients on this variable ended up being opposites. I have a positive 4 here and a negative 4 here. So that when I go to add these together, those cancel each other out. Then I get 11y equals negative 33. So I'm in a situation where I eliminated one of the variables. This is why it's called the elimination method. I eliminated one of the variables, and that means I can finish solving this by dividing both sides by 11. I get y equals negative 3. Since I have my y coordinate, let's find the x coordinate. I'm not seeing a particularly motivating reason to plug into either of these equations, but the first equation has smaller numbers, so I'm going to plug into that one. We get 2x plus 3y equals negative 6. I'm plugging in y equals negative 3. So 2x plus 3 times negative 3 equals negative 6. And that's 2x minus 9 equals negative 6. I add 9 to both sides. I get 2x equals 3. And thus x equals 3/2. I'm not terribly confident about this answer, though, 3/2 comma negative 3, because I ended up with a fraction for one of the two coordinates. And that seems a little bit weird to me. But fortunately, I know how to check my answer. Do it like this. I know how to check my answer, so that's what I'll do. 2 times 3/2 plus 3 times negative 3. I expect this to be a negative 6, and it is. Okay. Negative 4 times 3/2 plus 5 times negative 3. I expect this to be a negative 21, and it is. So despite ending up with a little bit of a weird answer, we have a 3/2 in there for our x-coordinate. Despite ending up with a little bit of a weird answer, I'm actually now confident in my answer. That confidence in getting the correct answer is actually quite important with questions like this. It allows you to move on and not think about that question again. I think it goes a long ways towards relieving anxiety.